For Chapter 4.1, we are going to continue our work with areas of parallelograms, and a key purpose that I'd like you to keep in mind is that you can derive or come up with the formula for finding the area of a parallelogram by using what you know about the area of a rectangle. And we did that with our activities in class recently. And you guys were doing a great job of noticing the patterns or the relationships that rectangles and parallelograms have. So keep that in mind as you continue to work through these formulas. The area of a parallelogram is the product, which we know means multiplication, and it's the product of its base and its height. And the formula that we're going to use is going to be written the same way each time. So it's going to be A equals B times H, and remember it's okay to put the B and the H right next to each other with no multiplication sign because they're variables, but you know when you go to start substituting in numbers for those that you'll put a multiplication sign. If you want to put a dot or a parentheses to mean multiplication here, you're more than welcome to. And remember in this case that A stands not just for area, but specifically for area of a parallelogram, because we're realizing now that different polygons have different formulas for area. And then B in this case stands for base, and H stands for height. For example 1, we're going to be finding areas of parallelograms, and the first one they give us here is letter A, and you can see your parallelogram here. And the first thing we'll do is we will write our formula, and the formula is capital A for area equals B for base times H for height, and then we just fill in order to help us solve. So we do know the base of this one is 12 meters, so we'll put 12 in here. We're not going to worry about putting M for meters right now. We'll worry about that at the end. And then we can see that the height here is 14 meters because that is the line that goes perpendicular or straight up or straight down from a corner to its opposite side. And if you could visualize or picture that if we were to take this little piece or this little triangle off and we were going to move it around here, whoops, move it to that one, move it around and drop it in over here, that we would be able to complete our rectangle. So that's our height of 14 meters, and we're going to put that in with some kind of multiplication sign because we know we can't put just 12 and 14 next to each other without anything. And then you'll do the side math or whatever kind of computation or calculation you have to do, but 12 times 14 is 168. And then we do remember that we have to label it correctly, so it said meters, and we know area is going to be squared, or if you feel more comfortable writing it as 168 square meters, that is another option. For letter B, the example is another parallelogram, but this one is different for a couple of reasons, but we're still going to tackle it the same way. We're going to use capital A for area of a parallelogram, and then we're going to use B for base and H for height. And one of the things you'll probably notice is that this particular parallelogram can look a little bit like it's on its side, and most of our base numbers so far have come from the side, but the side has been kind of laying down flat, and in this case it doesn't really matter because we know the properties of multiplication say that either order we put them in we'll still get the same answer, but technically this is still your base number, so we're going to go ahead and fill in 8.5 for base, and then we're going to multiply that by the height right here. And again, the reason we know this is the height more than anything is that it starts at one of the corners and then it goes straight across perpendicular to a different base, which of course is the same length. So we're going to stick in 4 as our base. And then the only other thing about this one to remember is that, of course, we've got some fractions and mixed numbers. So one thing we'll remember when we deal with that is that we've got to turn that into an improper fraction by multiplying your denominator by your whole number, and that's 16 plus add your numerator, which is 17, and we're going to keep the 2 as our denominator. And then to multiply that by 4, as an improper fraction, we just stick that one over 1. And then we do want to use all of our cross-simplifying tools. 17 and 1 can't go any lower, but 2 and 4 can both be divided by 2. And when you do that, 4 divided by 2 becomes 2. 2 divided by 2 becomes 1. And I'm just going to move that up there for a minute so I have a little bit more space to work. And then we're going to rewrite those fractions. So 17 over 1 times 2 over 1, and then you just multiply 17 times 2, which is 34 over 1, or that's the same thing as just 34. And then we check our label, which was feet, and we remember that all areas should be square feet or feet squared. Here are a couple of on your own problems to try. Remember to use the formula each time. Start by writing that down, and then after you do all of the work for those problems, then remember that your area is always going to be measured in square units, so check all of your labels. And just kind of keep in mind that number 2 here is doing something a little bit different. They've got the height on the outside of the figure, but if you were to notice here and pay attention to kind of what parallel means, then we know that we could drop that right in here and have it be the exact same. And so that 18 inches is just the same outside as it would be on the inside. So hopefully that'll help a little bit. For example 2, we're going to be finding the area of a parallelogram on a grid, or using this kind of graph paper like what we were doing in class. So this is the first figure that they give us, and the first thing that we can do is count the grid lines to find the dimensions. So over here we have the base, and we can see we've got 2 squares. Now even though this one isn't a complete square and this one isn't a complete square, we still are counting base, so we're really just paying attention to the fact that this has got a whole line across it and this has got a whole line across it. So that would be considered 2. And then the height we can put wherever is most convenient, but it has to be from one corner to the same distance across, straight up. So one way to do that is to just pick a corner that's at the top. It really doesn't matter if you pick this corner or this corner. You can even pick one of these 2 corners and go up if you need to, but you're going to take one of those and you're going to go down till it's equal to here, or up until it's equal to here. I'm going to go down in this case, so I'm going to go from 1, that's 1 square, 2, 3, 4, 5, and so I can see that distance is 5, and I can check it just by kind of going across here, making sure it lines up, and it does, and knowing that I have a right angle in there, so we know that it's the perpendicular line. So this is 5 units, and then we can use that same formula that we've been doing now that we've determined the actual measurements there, and we can do area equals base times height, and we know we said that the base is 2, and we don't have an actual unit of measurement, so we're just going to deal with the 2 for right now. And then the height we said was 5, which luckily that's pretty easy to do in your head. You've got 5 times 2, which is 10. And because there was no official unit of measurement, we just say units squared, or you can say square units as your final answer there. Okay, remember for this on your own problem, you're going to have to find your base and find your height and write in your correct measurements. You don't have to draw out the entire grid. I probably should have mentioned that on the last example. You can just sketch what would be a parallelogram similar to this, and then you can fill in your base and your height numbers, and then you don't have to worry about drawing all those extra squares. For example 3, you're going to do a real-life application, and the problem says you make a photo prop. So this would be kind of like one of those things where you can stick your face in around the scenery and get your picture taken. So you're making a photo prop for a school fair, and you cut a 10-inch square out of a parallelogram-shaped piece of wood. What is the area of the photo prop? So we know that this is sort of that parallelogram-shaped piece of wood, and they gave us the dimensions for that, Oops, not a very straight line. That's okay. Gave us the dimension for that, but then you also have to pay close attention to the fact that this square is missing, so you can't count that as the overall area. So what we're going to do is we're going to start by thinking about what this means. The overall area of the photo prop is going to be equal to the area of the wood, or the parallelogram shaped wood. So we're going to put parallelogram. I'm even going to abbreviate that this time. But then you would have to subtract from that the area of the square cutout. And once we understand that, then we can just start to put in the pieces that we know. And what we know is that the area of the parallelogram is going to be 4 feet times 8 feet. But before we write that down, what we have to pay kind of close attention to is that these numbers are in feet, but this one is in inches. So to make our lives a little bit easier down the road, we're going to convert all of those into one unit or the other. And in this case, I think it's easier to go from feet to inches. So we know that we can multiply 4 feet times 12, because 12 inches equals 1 foot. And then that will tell us how many inches we have here. And we can do the same thing down here to see how many inches this would be. So 4 times 12, of course, is 48 inches. And then 8 times 12 would give us 96. And you can use your multiplication chart or side math, whatever you need to do to figure that out. So our base here would probably be this number right here. This is probably our base, and that's 4. And then we could use our height, or we can switch those around because our properties say it doesn't really matter. So we can use this as our base. So we'll go ahead and stick in 96 times 48. And that's going to give us the area of the parallelogram, but we don't want to forget to subtract the area of that square cutout. And that says 10 inches times 10 inches. And of course, squares are equal on all sides. So that's just going to be equal to 10 times 10. And then you're going to have to do some side math for 96 times 48, but I've done that, and the answer is 4,608 minus 100. So the overall answer of the problem, I got to shrink that a little bit to give us some room. Okay. But the overall answer here then would be 4,508, and it is in inches now because we converted everything here to inches and to inches up here. So we've got 4,508 inches squared, or square inches. This last on your own problem is very much like that real life example we just did, except for it just doesn't have a story to go along with it. But you can see that you have a parallelogram here, but you can also see that you have a rectangle inside that is white or kind of cut out. So the shaded region would be all of this kind of yellow spacing in here, and then you have to take away that unshaded region, or that white piece that's not filled in. So it's going to be more than one step, but one thing you'll notice on this one is that everything at least is in feet, so you don't have to do any conversions when you do your work.